just like you would, and you know you would. And what's the reason for that? If you look, as you can see, there's a worn path, just like in every field and every park, there's a worn path where people have cut across. So do you think to yourself, after all your years of schooling, do you think, hey, that's the Pythagorean shortcut? Probably not. Okay, so why do we do that? The answer is not because humans are, it has more to do with, as the rapper Mos Def put it, it's strictly mathematics. Okay, so we don't think to ourselves, hey, that side length is shorter than the other two side lengths put together. Or we don't say to ourselves, the square on the hypotenuse is equal to the sum of the square on the other two sides, right? We just cut across because we know that it's faster. And it is mathematics. Here's another example right beside my kids' lovely school. An example of the Pythagorean shortcut on a hill. Okay? But this time it's stretched in 3 dimensions. And wouldn't that blow kids' minds? If you were to draw that triangle on a balloon, for example, what happens to the angles? But this blew kids' minds, right? Because they never thought of the mathematics this way. Okay, that Pythagorean shortcut is in every textbook in the last 100 years, but it's also in our world. Secondly, when we let kids play with interesting math, this sort of thing happens. So all I did was a kid put these, we were playing with the squares, right? So again, the sum of the 2 squares equals the sum of the other squares. But he said, okay, these 3 squares can't make a right-angled triangle. And truly they can't, okay? But this is an example of the sort of thing that kids wonder if we let them. Because, you know, none of us get out in the world and we say, I just really, really stink at reading. We don't tend to say that. The negative messages about mathematics are a little more common, and we don't want that. Stanford education professor Jo Boaler has been quite influential on that. She talks about mathematical mindsets, and we need to have them, and we need kids to have them. So negative messages like this don't help us. So with my own children, inspired by my own practice, I was thinking, you know, what happens when we just play with numbers? Okay, and none of us remember this, but we learn to count. We're born with something inside us, some sense of number, 1, few, many, depending on what culture we're born into. But so I said, what's a big number? And I got 5, because they were both quite little, and then I got 10. So this 10-ness, we can count out 10 objects. Kids learn to do that, sometimes by rote. Then they know that 10 objects is 10, okay? Having 10 cookies is a good thing. So this is how they get along their way, and then eventually they learn that numbers get bigger and bigger and bigger. So we were just playing around on a piece of paper, and I said, you give me a big number. So finally, I got million out of them, right? And so I said, well, okay, what if you add 1? Okay, well, that's a bigger number. And then we started talking about what happens if you add some zeros. And they were seeing that you could have this long string of numbers. And that surprised them because they're so little. And they don't understand place value, the number system, anything like that. We were just playing. But then so Callum, in his room, he emptied his piggy bank because he just couldn't keep that, you know, $2.42 in. So he dumped it on his bed. For some reason, I don't know why, he was naked at the time. And so he says, I have infinity money. I have more money than I can count. So he's counting it. He's like a young Scrooge McDuck or like a young Montgomery Burns or even like a young Donald Trump, and he's counting it, right? And so isn't that an interesting definition of infinity? And we don't teach that in school. Trust me, we don't. So now if you think of infinity is more than you could ever count in an infinite number of lifetimes, this lifetime or any other, that's a pretty interesting definition. He has no training in math. He wasn't in school yet. And then just from 2 days ago, I got this from Twitter because that's how I operate. I said, what do kids say about infinity? And so Jennifer Santuoso's grade 7s in Peel District School Board said this, and I give Cole Griffin and Owen a lot of credit for this. It's the thought of a number that never ends. But because it's so indescribable, as the equation shows, it doesn't matter if we add 1, subtract 1, or add 1, same thing. It's still infinity. So all of a sudden, it's something gigantic and massive that you can wonder about, something that mathematicians work on, but yet 12-year-olds can grapple with. Just another example of a problem that's out there. So I give you the proposition. I say, I'll give you a penny now, and then I'll give you 2 more tomorrow. Do you want that for 30 days? Or do you want $1 million? And kids are always all like, just give me the $1 million right now. And they tell you what they're going to buy. But when they start doing the math, they're surprised, right? So after 10 days, you have $2 or something. But after 30 days, you have this pile of pennies worth around $10.3 or $10.7 million. And so that's the power of exponential growth. But they don't know it as that, but they're surprised. And it's an interesting result. Just another example of something that's interesting. Numbers themselves, okay? So the 100 square is pretty common in school. We teach kids to count by twos, count by threes, factors of 24. But what's pictured in yellow are the prime numbers, so those indivisible little atoms of numbers. And so there's no real visible pattern, okay? If we did multiples of 2, there'd be a pattern there. It would be columns. It'd be nice and neat. Kids are really interested in that, in my experience. They seem to get more spread out as a system. So interesting and so intriguing. And so what do kids think when they get to school? One kid in grade 6 said math is a way of describing this world. And she wanted to go to things like money, but how much, and then baking, but how long. And these things are important. Well, they're quantifiable, right? And do we want kids to come out of school and come home and say, I had math today, we learned how to describe our world? Or do we want to leave grade 12 or college and university, we leave all our schooling and we say, hey, I learned math, I learned how to describe the world? I think that's a pretty good outcome. But what do my own children say? So Callum on the top, I'm just admitting it right now, I said, what is math? He just repeated that back from a couple of weeks before. He doesn't know what multiplying is. Infinity times infinity is still infinity, but that's what he said math is, which is fun. But so Alec in the bottom left, he said 1 + 1 is 2. Try it. If you know a 3, 4, 5-year-old, say, what is math? Kindergarten age students, they'll give you an example of arithmetic. And math surely is arithmetic, but it's a whole lot more of that than that. Arithmetic is interesting. Kids will say that. They'll just give you that one example of the fact they know. Just one of those mic drop moments. So I put it out to Twitter. And so Malka Rosenfeld's daughter, LZ, said space and time, any distance, and numbers. Okay? So again, do we want kids to come home from school and say, I use math today? It's all about space, time, distance, and any numbers. I think we'd like that. That'd be pretty amazing. But sometimes what does happen, okay? And so Jamie Mitchell, great teacher in Burlington, his daughter Stella, and I hope you don't feel this way. He says math is numbers. She says math is numbers and annoyingness and hatred. I want to start the hashtag Save Stella and all the Stellas out there, because math is more surprising, wonderful, and interesting than that. Somehow she's got there in her school experiences, and her math teacher father is quite heartbroken about it. But I love this quote because, no, not all kids feel that way, but some do, okay? So what if every kid came out of school and they said math is surprise and wonder and playing with number and a whole lot more than that? But what if they said that? That would be a pretty great outcome. And so taking you through where I sit as a teacher of mathematics in the school system. So this is school board materials from 1991. And what they're basically saying is teachers aren't going to teach like you were taught. And that's true. And sometimes parents want to come in and get mad about us. And we've all seen maybe those like Common Core math things that go viral on Facebook. Parents get mad. Okay, so back up to 1957, Russia launches a satellite called Sputnik. The space race has started. America says we're not good enough. We're not as good at the Soviets as good at math as the Soviets. And so they invent something called the new math, 1957. So almost 60 years later, we're still fighting. This is right after 1989. The details don't matter, but continent-wide reform. National Council of Teachers of Mathematics in the United States. We decide we want to change it. We decide the old ways won't do. 1991. Okay, we still have these same conversations. So there's new math, there's old math, there's new old math, there's old math, and we're still fighting. Okay, sometimes we do call it the math wars. And so what happens, how are we portrayed in the newspaper? You know, I track this stuff. People say don't read the comments. I say always do. Under every article about math test scores, math teaching, you could hold me to this. Kids these days, they can't make change. It always appears about it. So, math is about a whole lot more than just making change. And yes, kids should be able to make change accurately, but we have machines called cash registers just to do that. And we're better at thinking, and cash registers are good at carrying out routines. So what do we need in our classrooms? We need kids to be skilled with number concepts. We need them to be skilled with arithmetic. But we need them exposed to the big, powerful, and interesting concepts. Make no mistake about it. And we need our classrooms to be wide open spaces for students thinking, okay? Because we're born into it. That's our human birthright, an uninterrupted stream of consciousness that we're born into from birth until death. We have that. We have our power of our thinking. And so do we teach primarily through worksheets or wonderings? Probably a little bit of both. Kids want to know if pi ever ends. I know because we had a wonder wall and some kid just stuck. I didn't write that. That's what kids want to know. They wonder. And I want for our classrooms that they're talking spaces. Kids should talk to kids. So math just doesn't happen between me and my textbook or me and my teacher. I talk to other kids. Talking changes everything in my experience. They should be wide open spaces for thinking, as I said, and kids should get to conjecture, which is to math as hypothesis is to science, right? Just advancing these powerful conjectures with their own thinking. And finally, wondering and grappling with really, really big ideas. Like, what makes a circle a circle? And one kid wondered that, and it's actually a really profound question. So we can say it's the most perfect expression of circumference compared to diameter, and that ratio is pi. But I don't know if that's satisfactory to a kid or not. Or what happens if you slightly deform it? We all know what happens to our car tires if it starts going flat, for example. Kids want to know. Kids want to know things like this. How many people have lived on this planet? We can apply mathematics and reasoning to this. So we can come up with an estimation tool, and it's checking for that reasonableness. And kids could come up with an interesting number. Really interesting question. This one you probably can't read, but it says if you divide a number up so much that it equals 0, is that number actually infinity? Okay, so you can't actually divide by 0. But you imagine if I divide any number, like 8, and I divide that number by the number next to 0, for all intents and purposes, I would have an infinite number of parts. And this kid was reasoning that through. But that something happens at 0, right? You just can't do it. And kids want to know. And it's not in our curriculum, but it probably should be. And so I say to you, let kids lead with the power of their thinking, because they have it and they must. Okay? Our classrooms must be thinking spaces for children, for all our students. And let student thinking lead is kind of my philosophy, and it's the reason why there's so many seemingly messy work. Because when you get in that moment and you get talking with them and you see that work develop, it's just amazing, okay? They start to find a pattern, as it says at the bottom. They lead with the power and strength of their thinking. This was a project we did for the Ministry of Education, so Loving the Math, Living the Math, it was called. And this picture I always love because it's all these different solutions to the same problem. They look different, they are different, they're reasoned out differently. There's different mathematics in a lot of them. So we had some teachers in a room looking at them. He said, what's all the different ways this question could be answered? And there was still more, okay? And that's surprise on the teacher end. We thought we knew what they were going to do, and they did something even better than that. Astonishingly diverse. And then you get kids like this one, his insight, so we have this triangle pattern. He saw it as groups of 3 being stuck on the side. That's what he circled. But he had to explain it to his classmates. It was about to burst out of him, okay? And other students saw the pattern differently, maybe growing up or down, and that's how he saw it, and he needed to share it. But these sudden, startling insights, these eureka moments, where they're surprised and stunned even by the thinking, we need that. This is one of my favorites. So if I offer you $20 off, or if I offer you 20% off and you have to pick, well, he reasoned out that $100 was the tipping point for that, so where the discount becomes better, basically. And this was his hypothesis, but the story is a little better, okay? The teacher in that classroom said, he's He's on special education support. He never talks. This kid hates math. But he was the one, and he was working with a couple other kids. He needed to share this so badly because his thinking was activated. Okay? He understood the context, I guess, about shopping. He understood. He had this insight, and he needed to share it. And that's what we want. Those reluctant kids that are just, it's bursting out of them to share their thinking. And they surprise us. The teacher was surprised, and this happens over and over and over again when you let kids talk to each other. And we want all of us saying this: I know when I'm being ripped off. And so would we want our sons and daughters, nieces, nephews, and friends, would we want from ourselves that we come home from school and say, I learn how to use mathematics. I know when I'm being ripped off. I think that's pretty good. It just had to do with soft drinks, pop, but they said, they reasoned out, they said, I can't take this, it's a ripoff. And that leads to this next one, is one of my favorites. I walked down the hall and I said, $1.50 for 32 grams of baked potato chips? Are you kidding me? Nobody even likes those. And so I came up with this problem, right? What's a fair price? And so one kid said 27 cents. And they looked up a bunch of chips on the internet and some flyers, and 27 cents was what they came up with. And then they knew from the power of their own mathematics. I'm assuming they never bought these again. And so, great book, How Not to Be Wrong by Jordan Ellenberg. There's no equations in it. I highly recommend it. But he called mathematics the extension of common sense by other means. And I would love for all of us, if we say, hey, I went to school, I learned math to extend my common sense by other means, and those means are mathematics, I would love that for all of us and for all the children out there. I would like it very much if we saw mathematics as a source of surprise and wonder, and not just something that happens in textbooks, or not just something that happens in schools. And I'll give the last word to kids, as I always like to do, because they often say it best. So one kid in grade 6 said, math is the most powerful force in the universe. Use it wisely. Thank you very much.